Hello there, welcome to Csec Math TV. Today we will be looking at sums and products of roots of quadratic equations. Alright, so the objectives for today are to use the relationship between the sums and products of roots of quadratic equation in its standard form ax squared plus bx plus c equal to 0, and also utilize it as application of sums and products of the roots of these quadratic equations. Alright, so let's start with this equation right here. How do we solve this equation for x? X squared minus 7x plus 6 equal to 0. The basic essence is you can either use method 1 using the quadratic formula by substituting a as 1, b as minus 7, c as 6, and using the quadratic formula we're going to get two answers. The two answers we're going to get in this case simplifies to be x equals 6 or x equals 1. Now you may have done it by factorization, it doesn't matter, that's okay. Now we also know that the graph of the quadratic would smile. It would smile and pass through the y-axis intercept of 6, and the roots are 1 and 2. Those are the two roots. Now this is what I want us to focus on. Now what I want us to focus on is the two roots are 1 and 6. So if we were to look at the sum of the two roots, 1 plus 6 is 7. And observe that the product of the two roots, 1 times 6 is 6. Now look at the function f of x equal x squared minus 7x plus 6. That's 7 right there, that is the sum. And the 6 right there is the product. Makes sense. So given any quadratic equation in the form ax squared plus bx plus c equals 0. Let's say the roots are r1 and r2. Then we would know that the equation can also be rewritten as x minus r1 times x minus r2 equal to 0. Now if we were to expand that equation right there, then what we would get is x squared minus r2 times x minus r1 times x plus r1 r2. Factor out the x from the two middle term, we would get x squared minus r1 plus r2 x plus r1 r2 equal to 0. Now look at the first equation, the standard form, the ax squared plus bx plus c equals 0. If that equation, if we divided that equation by a, right, then that equation would simplify to be x squared plus b over a times x plus c over a equals 0. If we were to compare that equation to the equation that we got on the left side, x squared minus r1 plus r2x plus r1 r2 equals 0, by comparing the two equations, we can conclude that r1 plus r2 would be minus b over a. r1 times r2 would be c over a. Now if you're not seeing it straight away, just take a good look at it again. Alright, we're just comparing the coefficients of the two equations. So here's our conclusion then. So our conclusion is given any quadratic equation in the form ax squared plus bx plus c equal to 0, with the roots being r1 and r2, the sum of the two roots, let's call the sum s. S is going to be given by minus b over a. That's how we would find the sum of the two roots of a quadratic equation. The product of the two roots p, which is r1 times r2, can be found by c over a. Quadratic equation can also then be rewritten as x squared minus the sum of the roots times x plus the product equals 0. Those are the three things that we must remember. These are key. The sum of the roots, the product of the roots, and how we write the quadratic equation. Let's check and see if it is true, right? So given the quadratic equation, 3x squared plus 4x minus 4 equals 0, right? We're just testing out if the formula is true. By this quadratic equation, our a would be 3, our b would be 4, and our c would be negative 4. And so the sum of the roots would be minus b over a, which works out to be negative 4 over 3. The product of the two roots would be c over a, which is equal to negative 4 over 3. Now let's test the truthfulness of it. If we were to solve this quadratic equation for the two roots, and we can do it by factorization, we'll see that it would simplify to give us that the roots are x equal 2 over 3 or x equal to negative 2. If we were to add those two roots, 2 over 3 and negative 2, notice we still get in the burgundy color minus 4 over 3. And if you were to look at what we get in the blue color, the product of the roots is also minus 4 over 3. The same as where the arrow started above up there. So see that the formula is indeed true. Whether you go ahead and find the two roots and then add them, you're still going to get that the sum is minus b over a. And whether you want to find the two roots and then multiply them, you see that the product of the two roots is c over a. Now, this is very useful because in exams, they're going to ask you to write down the sum and the product of two roots of a quadratic without solving the equation. So let's look at a typical example. So this question says, given the roots of the quadratic equation, 225 minus 16x minus x squared equals 0 are alpha and beta. Without solving the equation, write down the value of alpha plus beta and alpha beta. So to do this question, the first thing we are required to do is to put the equation in standard form. Putting it in standard form, we're going to get minus x squared minus 16x plus 225 equal to 0. From that, we're able to identify our a, which is negative 1, our b, which is negative 16, and our c, which is 225. Using the formulas that we said, the sum of the roots, which is alpha plus beta, is now minus b over a. So it's negative 16 over negative 1, which is negative 16. And the product of the roots, which is alpha times beta, would be equal to c over a. That's 225 over negative 1, which is negative 225. And so that would be the sum and the product of the two roots. Now if you don't believe me, you can go ahead and solve the equation for the two roots and verify that your answer is true. So here's a question for you to try. It says, given the roots of the quadratic equation 3x squared plus 2x minus 5 are p and q. Without solving the equation, write down the value of p plus q and the value of p times q. Well, as you would have paused and attempted, the first thing we're supposed to check for is it in standard form. In this case, luckily it is. So a is 3, b is 2, and c is negative 5. So using the formula, the sum of the roots, which is p plus q, is now minus b over a, so that's negative 2 over 3. The product of the roots is then p times q. And p times q is c over a. c is negative 5, a is 3. So the product of the two roots is negative 5 over 3. That's your answer. Nice. Alright, now let's look at a different style of question here. Given the roots of the quadratic equation are 3 over 2 and negative 5 over 4, write down the quadratic equation. So pause and attempt. Alright, so in doing this question, the roots are 3 over 2 and negative 5 over 4. Remember what we said, the third thing you're supposed to know? Any quadratic equation can be expressed as x squared minus the sum of the roots times x plus the product equals 0. So we use s to represent the sum of the roots and p to represent the product. So the sum is going to be 3 over 2 plus negative 5 over 4, which is a quarter. And the product is going to be 3 over 2 times negative 5 over 4, which is negative 15 over 8. So then the equation of the quadratic is going to be x squared minus 1 over 4 times x. Replace the s with the quarter we found. And then replace the p with minus 15 over 8 equal to 0. Now, we don't like to have fractions, so we're going to multiply the entire equation by 8. Multiplying the entire equation by 8 allows the quadratic to simplify to be 8x squared minus 2x minus 15 equals 0. Now, I know many persons may have wanted to write down the quadratic by saying that the factors would have been 2x minus 3 times 4x plus 5. But if you did it that way, you'll realize that you still get the same answer. Alright, that's because any quadratic can be written in this form. Alright, so let's look at a fully blown exam style question now. These are the questions that you'll see typically in exams. So let's have a look at it. It says, given the roots of the quadratic equation 4x squared minus 6x plus 15 are alpha and beta. Without solving the equation, write down the value of alpha plus beta, alpha times beta, alpha squared plus beta squared, and write down the equation with the roots alpha squared and beta squared. So pause the video and attempt. Again, we know what we should start with. Check to see if it is in standard form, and yes it is. So we can write down A is 4, B is negative 6, and C is 15. So we can end up tell them that the sum of the root, which is alpha plus beta, is minus B over A. So it's negative 6 over 4, which is 3 over 2. The product of the roots is alpha times beta, and that is given by C over A, which works out to be 15 over 4. So alpha plus beta is 3 over 2, and alpha times beta is 15 over 4. Now part C says to find alpha squared plus beta squared. Now we don't know how to do that, but we only know the value of alpha plus beta and alpha times beta. We know those two values displayed on the screen here. But look at this. Alpha plus beta all square would be alpha plus beta times alpha plus beta. If we expand that bracket, we would get alpha square plus alpha beta plus alpha beta plus beta square. So observe that alpha plus beta all square is equal to alpha square plus 2 alpha beta plus beta square. Notice we put alpha square plus beta square in black, because if we can make alpha square plus beta square the subject, then we see that alpha plus beta all square minus 2 alpha beta is equal to alpha square plus beta square by transposing. And so we know what alpha plus beta is. That is 3 over 2. And we're just going to square it. Minus 2 times, we know what alpha times beta is. That's 15 over 4. Substituting those into the equation and putting it in our calculator, we get negative 21 over 4. And so alpha square plus beta square is negative 21 over 4. And that is how you would do part C. Alright, so you should be laughing at this question now. It seems so difficult, but we have to always utilize alpha plus beta and alpha times beta. Write the equation down with roots alpha square and beta square. Now that seems dangerous, but again, remember we said any quadratic equation can be written in the form x squared minus the sum of the roots times x plus the product equals 0. The sum is going to be alpha squared plus beta squared, and we just found that that is negative 21 over 4. Now the product of the two roots is going to be alpha squared times beta squared, because the two roots are alpha squared and beta squared. Multiplying those, we would get alpha squared beta squared, which is alpha times beta all squared. So that works out to be 15 over 4 all squared, which works out to be 225 over 16. So we're going to replace the sum with negative 21 over 4 and replace the product with 225 over 16. And so the quadratic equation is x squared minus 21 over 4 times x plus 225 over 16 equals 0. We can then multiply through by 16 to get rid of the fractions, and so this equation would simplify to be 16x squared plus 84x plus 225 equal to 0. So that would be the equation with roots alpha squared and beta squared. So here's one more question for you to attempt. So pause the video and attempt this question. Alright, so the first part is straightforward. The sum of the roots, which is alpha plus beta, is minus b over a. So that is negative 1 over 6, which is 1 over 6. Cool. Now the product of the roots, which is alpha times beta, is then c over a. So that is now negative 15 over 6, which works out to be minus 5 over 2. So we can write down that alpha plus beta is 1 over 6 and alpha beta is negative 5 over 2. So here's the real challenging part now, to write down the equation down with roots alpha over beta and beta over alpha. Now first thing, we only know what is alpha plus beta and we know what is alpha times beta. So if the roots are alpha over beta and beta over alpha, we know any quadratic equation can be written in the form x squared minus the sum of the two roots times x plus the product of the two roots equal to 0. So the sum of the two roots will be alpha over beta plus beta over alpha. Now finding the sum of those two roots, we use the LCM. The LCM is going to be alpha times beta. Now beta into alpha, beta leave alpha, and alpha times alpha is alpha squared, plus alpha into alpha, beta leave beta, and beta times beta is beta squared. So we end up get that part, the sum, simplifies to be alpha squared plus beta squared over alpha beta, writing it as one fraction. Now we just found from the previous video that alpha squared plus beta squared is equal to alpha plus beta all square minus 2 alpha beta. So we can substitute alpha plus beta as 1 over 6 and alpha beta as negative 5 over 2 into that equation, and it's going to simplify to give us 181 over 36. So that means the sum, which is alpha over beta plus beta over alpha, remember it is alpha squared plus beta squared over alpha beta, but the numerator part of it works out to be 181 over 36, and alpha times beta is minus 5 over 2. Put that in your calculator, you get negative 181 over 90. Next we need is the product of the two roots. Now alpha over beta times beta over alpha, if you multiply those, you get 1. And so the equation of the quadratic is just going to be x squared plus 181 over 90 times x plus 1 equals 0. Because remember, we just replace the s and the p with the values that we get. And so multiplying through by 90, the equation becomes 90x squared plus 181x plus 90 equal to 0. And so that would be the quadratic equation with roots alpha over beta and beta over alpha. Really nice. So just a summary of what we should remember. We should remember that alpha plus beta is minus b over a. Alpha times beta is c over a. Alpha square plus beta square is alpha plus beta all square minus 2 alpha beta. Alpha over beta plus beta over alpha is alpha square plus beta square over alpha beta. And the quadratic equation can always be written in the form x squared minus the sum of the roots times x plus the product equal to 0. Hey! And so, just refresh our memory of the objectives we looked at. So that's it for today. And so see you next time. Keep on practicing. Alright, stay safe.